Welcome. Today, we'll explore how to build embedded projects faster and more efficiently. Whether you're a hobbyist or a professional developer, understanding the right approach can save you time, money, and frustration. Embedded systems are everywhere, from smart home devices to industrial automation. But what does it take to bring an idea from concept to reality quickly? In this video, we'll break down the process into clear stages, share practical tips, and highlight common pitfalls. Let's dive in and discover how you can accelerate your next IoT or embedded project. Internet of Things, or IoT, is a powerful concept that brings together hardware, firmware, cloud services, and user-facing applications. It's not just about connecting devices, it's about solving real-world problems by making things smarter and more responsive. IoT projects often require a blend of engineering disciplines, from electronics to software development. By understanding how these elements work together, you can design solutions that are robust, scalable, and user-friendly. Let's see how this integration shapes the development process. The heart of every successful embedded project is a clear focus on solving real user problems. It's easy to get caught up in technical details, but the best products address genuine needs. Before you start designing, ask yourself, what pain point am I addressing? How will users interact with my device? By keeping the end user in mind, you'll create solutions that are not only innovative but also practical and valuable. This mindset guides every phase of development, from initial concept to final launch. Embedded and IoT projects typically move through three main phases: proof of concept, prototype, and production. Each stage has its own goals and challenges. The proof of concept phase is about validating your idea quickly and cheaply. The prototype phase focuses on refining your design and testing usability. Finally, the production phase prepares your product for real-world deployment. Understanding these stages helps you plan effectively and avoid costly mistakes down the road. Early planning is crucial for any embedded project. By mapping out your goals, requirements, and constraints from the start, you can reduce costs, minimize risks, and avoid unnecessary delays. This means thinking ahead about hardware choices, software architecture, and integration points. Good planning also involves anticipating potential challenges and setting realistic timelines. The more thorough your preparation, the smoother your development journey will be. First stage in building an embedded project is the proof of concept. Here, the goal is to quickly test your core idea using simple tools like breadboards or development boards. This approach allows you to experiment with sensors, connectivity options, and basic hardware without committing to expensive custom designs. By keeping things simple, you can validate feasibility and identify potential issues early on. Let's look at how to make the most of this phase. During the proof of concept phase, it's important to test key components like sensors and connectivity modules. This means wiring up your hardware, writing minimal code, and checking if everything communicates as expected. By focusing on the essentials, you can quickly determine if your idea is technically viable. Don't worry about perfecting the design at this stage, just make sure the basics work before moving forward. The early stages, your software should be minimal, just enough to demonstrate the core functionality. This might include a simple app, a basic front-end, or some back-end integration. The goal is to prove that your hardware and software can work together, even if the interface isn't polished yet. By starting small, you can iterate quickly and avoid wasting time on features that might change later. Once your basic system is up and running, it's time for early field trials. This means taking your prototype out of the lab and testing it in real-world conditions. Field trials help you validate feasibility and uncover issues you might not see in a controlled environment. Gather feedback, observe how the device performs, and use these insights to guide your next steps. Early testing is key to building a reliable product. After validating your concept, it's time to move to the prototype stage. Here, you'll develop a custom PCB and select the right components for your design. This phase is about refining your hardware, improving ergonomics, and making the device look and feel more like a finished product. Prototyping bridges the gap between a rough idea and a market-ready solution. Designing a custom PCB is a major milestone in embedded development. This step allows you to optimize your circuit for performance, size, and cost. Carefully select components that meet your requirements and are readily available. Good component choices can simplify manufacturing and improve reliability. Remember, the prototype is your chance to experiment and refine before committing to large-scale production. Make your prototype more user-friendly. Consider using 3D printed enclosures. These custom cases help you test the look, feel, and ergonomics of your device. A well-designed enclosure can reveal design flaws and inspire improvements. Plus, it gives stakeholders a tangible sense of the final product. Don't hesitate to iterate on your enclosure design as you gather feedback. The more refined prototype, it's time for larger field trials. Deploy your device to a wider group of users and collect detailed feedback on usability, performance, and reliability. These trials help you identify issues that may not have surfaced in earlier tests. Use the results to guide firmware and hardware improvements, ensuring your product meets user expectations. Based on feedback from field trials, refine your firmware and software. This might involve fixing bugs, optimizing performance, or adding new features. Iterative improvement is key. Don't expect perfection on the first try. By responding to real user input, you'll create a more robust and user-friendly product. With your prototype in hand, it's time for comprehensive testing and versioning. This stage ensures that your hardware, firmware, and cloud integration all work seamlessly together. Rigorous testing in real-world conditions helps you catch issues before mass production. Versioning allows you to track changes and improvements, making it easier to manage updates and maintain quality. Test every aspect of your hardware and firmware to ensure reliability and performance. This includes stress testing, compatibility checks, and integration with cloud services. Comprehensive testing helps you catch subtle bugs and edge cases that could cause problems later. The more thorough your tests, the more confident you'll be in your product's readiness for launch. It's not enough for your device to work in the lab, it needs to perform reliably in real-world conditions. Validate your device's performance by simulating actual usage scenarios. Monitor how it handles different environments, power fluctuations, and network conditions. This step is crucial for building a product that users can trust. As you test your device, you'll likely discover areas for improvement. Make iterative updates to your software and firmware, addressing bugs and enhancing features. This cycle of testing and refinement ensures your product is as polished as possible before launch. Remember, continuous improvement is a hallmark of successful embedded projects. Once your device passes all tests, it's time to prepare for production. This involves finalizing your design, creating manufacturing documentation, and planning for scaling. Make sure your versioning system is up to date so you can track changes and manage updates efficiently. Proper preparation sets the stage for a smooth production and launch. Final stage is production and launch. Here, you'll manufacture your device at scale, launch it to the market, and onboard new users. Clear messaging and effective onboarding are essential for a successful launch. Make sure your support channels are ready to handle customer questions and feedback. A strong launch sets the tone for your product's success. A successful product launch depends on clear messaging and smooth onboarding. Make sure your marketing materials explain the product's value and how it solves user problems. Provide easy-to-follow instructions for setup and use. Good onboarding reduces user frustration and increases satisfaction, helping your product gain traction quickly. After launch, it's important to monitor your device's performance in the field. Use cloud-based tools to track usage, detect issues, and gather analytics. Monitoring helps you respond quickly to problems and identify opportunities for improvement. Stay engaged with your users to ensure your product continues to meet their needs. Customer feedback is invaluable for ongoing improvement. Encourage users to share their experiences and suggestions. Analyze this feedback to identify common pain points and areas for enhancement. By listening to your customers, you can make targeted updates that increase satisfaction and loyalty. One of the advantages of modern IoT devices is the ability to update firmware and software remotely via the cloud. This allows you to fix bugs, add features, and improve security without requiring users to return their devices. Make sure your update process is reliable and user-friendly to maintain trust and satisfaction. As demand grows, you'll need to scale your production and connectivity infrastructure. This means optimizing your manufacturing process, expanding your supply chain, and ensuring your cloud services can handle increased traffic. Scaling effectively ensures your product can reach a wider audience without sacrificing quality or reliability. Journey doesn't end at launch. Successful embedded projects are continuously improved based on user feedback and technological advances. Regularly review your product's performance, update features, and address any issues that arise. This commitment to improvement keeps your product competitive and relevant in a fast-changing market. Even experienced developers can fall into common traps when building embedded projects. Avoid overcomplicating your design, neglecting user feedback, or skipping thorough testing. Rushing through any phase can lead to costly mistakes later. By staying focused and following a structured process, you can sidestep these pitfalls and deliver a successful product. To speed up your embedded project, leverage development boards, open-source libraries, and modular components. Collaborate with experienced partners and use proven design patterns. Automate testing and deployment where possible. These strategies help you move quickly without sacrificing quality or reliability. Good documentation is essential for fast and effective development. Document your design decisions, code, and testing procedures. Clear documentation makes it easier to onboard new team members, troubleshoot issues, and scale your project. Invest time in creating and maintaining thorough documentation throughout the development process. Building embedded projects faster requires a structured approach, clear focus on user needs, and a commitment to continuous improvement. By following the stages of proof of concept, prototype testing, and production, you can bring your ideas to life efficiently and effectively. Remember to plan ahead, test thoroughly, and listen to your users. With these strategies, you'll be well equipped to tackle your next embedded or IoT project with confidence.